So the last 2 weeks of the semester, we're going to be talking about environmental exercise physiology. If this is something that you find interesting, I would invite you to consider taking PE 480 in the spring of 2022. During that class, I teach it. It's kind of my favorite class. And we basically take what we learn over these 2 weeks and then just spread it out over the summer. We do some labs using the environmental chamber, that sort of thing. We only offer it every other year, every other spring. So it'll be spring of 2023. I can't remember if I said that right earlier. So not this coming spring that starts in a couple weeks, but spring of 2023. All right. So got a couple of objectives for this video. So we're going to break the environment up into two parts. And then we're going to talk about heat balance. So that's the first day. So I want you to think about, how do we deal with the environment? And so when I talk about the environment, it's kind of your surroundings, right? And so there are all sorts of different things that affect the environment. And all of these can be considered stressors, or things that will take us out of homeostasis. Now for this class, we're talking specifically about exercise, which we've been talking about all semester, as well as heat, cold, and hypoxia. Okay, hyperbaria, which is listed here, that's what you experience when you do scuba diving. Okay, and so we're not going to talk about that in this class. We might talk about it in the environmental exercise physiology class. So whenever we come across a stressor, there's going to be some sort of adaptation. And so an adaptation is actually a physiological change, like it says here, that minimizes strain. Okay, and usually these are kind of maybe longer term things that happen to help us adjust. Okay, but they're just something that we do to minimize that strain. And so a couple of ways that we can do this is through the process of what we call acclimatization. And so this is a long-term change that happens as a result of being exposed to a natural environment. Okay, and so what happens is our normal typical response changes so that we can deal with this stressor. Now, there's also what we call acclimation. And so acclimation is essentially the same thing as acclimatization, only one occurs naturally and one occurs in an artificial environment. So acclimatization would be if you go hang out with my parents up in Utah, you will become acclimatized to low oxygen or lower oxygen. Whereas acclimation would be you go hang out in the chamber in the ex-phys lab all day, every day when it has low oxygen. Okay, and ultimately, this can lead to genetic changes. So this isn't something that you will experience. This isn't something your kids would experience, but this would be something that generations down the road would experience. So for example, let's just you decide that you want to live on top of a really tall mountain. Okay, so you and your friends go and you set up your little community, and you guys just live there, and your families live there for hundreds and thousands of years. There's going to be some genetic changes that occur that allow your, relatives to better survive or better thrive in that harsh environment. All right, and so we're going to break this up. With this one, we're going to talk about thermal terminology, and then on the next video, we're going to get into more terminology related to altitude. But with thermal terminology, we've got heat. And as I've said a few times, heat is just a measure of energy, of kinetic energy. Okay, and so when you've got a gas like the atmosphere, molecules are in motion, and the speed with which they move produces heat, and with that heat, that's how we measure temperature. Now, what's important to know about heat is it's energy that we can do a variety of different things to. We can store it, we can convert it, and what that means is we're just changing it from one type of energy into another, and then we can also transfer it. And we're going to talk about that with the third video of this first day, when we're talking about heat transfer, actually. All right. It's important to know that with heat, it always moves down a gradient. It always goes from hot to cold. Okay, high temperature to low temperature. So temperature is just how hot or cold something is, and it's just essentially a measure of the average kinetic energy. And remember, kinetic energy is just the energy of something in motion. Okay, generally speaking, we express this in terms of degrees, okay, on one of our standard scales. And there are 3 scales that we can possibly use. Now, because we live in the U.S., the scale that most of us are familiar with is Fahrenheit. All right, there's us and there's Belize. Other than that, no one else uses it. And I'm not even sure Belize still uses it. Okay, So this is where water freezes at 32 degrees and where water boils at 212 degrees. There's really no method to the madness, but that's just one of the, I guess, unique things about the United States is that we don't want any method to the madness when it comes to measurement. That's why we don't use the metric scale, apparently. Then we've got Celsius, and Celsius makes a little bit more sense. With this, you go from 0 to 100. 0 is freezing, 100 is boiling of water. The problem with Celsius is you can have a negative temperature, and essentially, if you've got a negative temperature, what you're implying is that there's negative movement, and you can't have negative movement. And so what happened was they took this Celsius scale and they converted it into Kelvin. And so Kelvin is 0 means there's no molecular movement. That's the coldest you can get, absolute 0. And so at absolute 0, which is 0 degrees Kelvin, that's kind of where the scale starts. And so you go up from there. You can't have a negative temperature with Kelvin. All right. But with Kelvin, you reach freezing at 273 degrees, which sounds kind of crazy. Okay, and water boils at 373 degrees, and normal environment is close to about 290 to 300 degrees, depending on how hot or cold it is. Okay, so generally speaking, in science, we use Kelvin, but more often than not, we use Celsius. Now, the relationship between Celsius and Fahrenheit is given by this equation here. So Celsius equals 5/9 times Fahrenheit minus 32. You can also look at it this way, where you could say Fahrenheit equals 9/5, which is 1.8, times Celsius plus 32. Okay, and really what's important to know, or what's easy to remember, is that as you increase Celsius, your temperature by 10 degrees Celsius, you're actually increasing the temperature in Fahrenheit by 18. Now, fun fact too, is that negative 40 degrees Celsius equals negative 40 Fahrenheit. It's kind of where those two scales cross. All right, so to kind of give you a visual of this, so here we've got 0, here we've got 32, and so like we said, we go 18 up. We increase 18 for every 10 degrees Celsius, so we go 50, 68, 86, 104, and then 122. I've actually been in 50 degrees Celsius before. It was in June of 1990. I was a 13-year-old kid living in Mesa, Arizona, which is a suburb of Phoenix, a very large suburb. And we tried to fry an egg on the sidewalk that day. I can't remember if it worked or if the red ants ate it. But either way, it was hot, but it was a dry heat. Wouldn't want to experience it again, but I guess I can say that I did. Now, normal core temperature ranges from about 35 degrees Celsius to 40 degrees Celsius, with typical core temperature, at least textbook values, being 37 degrees, okay, which is 98.6. And so most of us have probably experienced just about all of these temperatures, or experienced most of this range, I would say at least from 0 to 40, but we keep our body temperature pretty tightly regulated. And we're going to talk about that more as we go on with this unit.